Hello everyone, Joshua here, giving you the answers to the first exam. I have a little bit of a cold, so sorry if I'm mumbling or sniffling a bit. I really can't do nothing about it. Let's get started. Problem number 1 asks us to compute the following. -3 squared times the quantity 1/2 plus 5/8 divided by 3/4. So right away we can compute -3 squared, and that is 9. And then you should also notice that we can, instead of having to divide by a fraction, we can multiply by the reciprocal, 4/3. So multiply the fractions together, multiply the numerators, you get 20. The denominators, you get 24. So then to add these two fractions, we'll need to get a common denominator. So I'm going to multiply by 12 over 12. And now this turns into 12 over 24 plus 20 over 24, which reduces to 32 over 24. And actually I wrote the wrong number. Okay, so then 32 over 24. What can we reduce that to? We could do, this will be the same as 16 over 12, which will be the same as 8, 6. So now we need to take 8, 6, multiply by 9, which we'll do is writing 9 over 1. And multiply the numerators, we get 72 over 6, which simplifies to 12. That's the end of problem 1. Problem 2 asks us to simplify the following expression, and we're given 3/4 x minus 2 times 5 over 6x plus 3 minus 2/5 times 10. So right away we can take care of the distribution, and then also I'm going to write 10 as 10 over 1 so we can multiply 2/5 and 10 together. So after doing that, we get 3/4 x minus, and we'll need to write 2 as 2 over 1 to multiply the fractions, 10 over 6x minus 6 minus 20 over 5. And 20 over 5, 20 divided by 5 is 4. So now we need to combine like terms. We need a common denominator between 3/4 x and -10 6x. Common denominator would be 12. Multiply 10 6 by 2 over 2. And multiply 3/4 by 3 over 3. And now we get 9 over 12 times x minus 20 over 12 times x, and then minus 6 minus 4 minus 10. And then when we combine the like terms, we get -11 over 12 times x minus 10. And we have simplified the expression. We can move on. Problem 3, divided in 3 parts. We're going to be solving equations. So we're going to solve for what x is. First problem, 3 times x minus 2 minus 2x plus 5. And that is in parentheses, equals 4x minus 1. All right, we can do some distribution. And if we write a 1 here, we can also distribute this negative 1 to those two terms. So after distribution, 3x minus 6 minus 2x minus 5 equals 4x minus 1. Combine the like terms on the left side, and we get x minus 11 equals 4x minus 1. Add an x, or actually we're not going to add an x, we're going to subtract an x from both sides. And while we're doing that, we might as well add a 1 to both sides as well. And we get negative 10 equals 3x. Divide by 3. And we get negative 10 over 3 equals x. Usually you write it on the left side, so why not? X equals negative 10/3. And you can check that by plugging it back in to the original equation. Part B, we're going to be solving 2/3 x minus 4 plus 1/4 x equals 3 minus x. So what I'm going to do first is get all the x terms on the left side and then all the constant terms on the right side. So to do that, I'll need to add 4 to both sides. And then I will also need to add x to both sides. After doing that, we get 2/3 x plus 1/4 x plus x equals 7. Now to add all those x terms together, we need a common denominator, which will be 12. So we're going to multiply 1/4 by 3 over 3. We're going to multiply 2/3 by 4 over 4. Oop, not 4 over 3, 4 over 4. And we'll need to multiply x by 12 over 12. Doing that gives 8 over 12x plus 3 over 12 times x plus 12 over 12 times x equals 7. And then when you combine all of those x terms, we get 23 over 12, x equals 7. And now to get x by itself, we'll need to multiply by the reciprocal, which is 12 over 23. Do that on the other side as well. Oop, not 23 over 12, the other way around. Write 7 as 7 over 1, so you can multiply those two fractions. And then, after doing that, we get x equals 84 over 23. And that does not reduce. We can move on to the next problem. Part C, the last solving an equation. we're given 2x plus 3 plus 2 times x minus 1 equals 3x minus 2 plus x. We can distribute this too, and we can also combine these two like terms on the right side, giving 2x plus 3 plus 2x minus 2 equals 4x minus 2. Combine like terms on the left side, 4x plus 1 equals 4x minus 2. We need to get all the x terms on one side, so we subtract 4x from the right side and the left side, but after doing that, you notice that we end up with 1 equals negative 2, which makes absolutely no sense, therefore no solution, because 1 never equals negative 2. Okay. Problem number 4. Find the equation of the line in standard form that passes through the point negative 6, 3 with a slope of m equals negative 1/2. We are given a point and a slope, so we're going to use point-slope form to write our equation before turning it into standard form. Point-slope form requires a point as well as a slope, and the equation is as follows. As a reminder, and the information we are given is the point negative 6, 3, and we're given a slope of negative 1/2. So upon plugging that information into the equation, we get y minus 3 equals negative 1/2 x minus negative 6. After distributing, and also noting that x minus negative 6 is x plus positive 6, we get negative 1/2 x. 1/2 of 6 is 3 times negative 1 minus 3. Getting it into standard form requires the y and the x terms on the left side. We're going to add a 1/2 x to both sides. And while we're at it, we'll add 3 to both sides as well, trying to get this 3 off the left side and onto the right side. But then you notice that it cancels out on both sides, leaving just y plus 1/2 x equals 0. Normally we want integer coefficients in standard form. To do that, we're going to multiply the entire equation by 2. After distributing this 2 to all the terms, we get 2y plus x equals 0. And our equation is now in standard form. Question 5 asks us to identify the x and y intercept of the equation of the line given above in number 4. So as a reminder, our equation that we just solved is 2y plus x equals 0. So we need to find the x and y intercept. All of the points on the x-intercept, think about looking at a graph. standard XY axis graph, all of the points on the x-axis have a y-coordinate of 0, right? They're all going to look like some x value and then 0. So we can just plug y in, or plug 0 in for y, and solve for x, and we get x equals 0, because 2 times 0, 0. So we know that the x-intercept is the point 0, 0. Now we're going to do the same for y. All the points on the y-axis have an x-coordinate of 0. They're going to look like that. So instead of subbing 0 in for y, we're going to do it for x. 2y plus 0 equals 0. 2y equals 0, divide by 2, and we get y equals 0. What do you know? Our y-intercept is also 0, 0. Okay, that's it for problem 5. Problem number 6, determine if the following lines are parallel, perpendicular, or neither. Justify your answer in one sentence. A line that passes through the points -3, 2 and 7, 8. A line given by the equation 3x minus 5y equals 15. So for the first line that we are given 2 points, but to write in equation we need a point and a slope, or a point and an intercept. In this case it's going to be easier to calculate the slope because we're given 2 points. We are given -3, 2, and we are also given 7, 8. So we can think about this as x1, y1, and x2, y2. And the slope formula is as follows. Taking that information, plugging it into the slope formula, we get 8 minus 2 over 7 minus -3. Minus -3, same as adding a +3, which yields 6 over 10, which reduces to 3/5. So now we have a slope, and we have either one of these points, so we can use point-slope form to write an equation. Look at, I believe it was problem number 4. If you need a reminder on point-slope form, I'm just gonna go ahead and sub the information in. Y, and I'm gonna use, I'm gonna use the first coordinate pair, so y minus 2 equals our calculated slope 3/5 times x minus -3 minus -3 again plus +3. We get y equals 3/5 x plus 9 over 5. Adding a 2 to both sides, because we want it in slope-intercept form, because we need information about the slope as well as information about the y-intercept to determine if it is parallel, perpendicular, or neither. Doing so yields y equals 3/5 x plus 9/5 plus 2. We need to get a common denominator between 9/5 and 2. So I'm going to multiply by 5 over 5, which gives y equals 3/5 x plus 9/5 plus 20, or 10 rather, 10, not 20, 10 over 5, which reduces down to y equals 3/5 x plus 19 over 5. So that is our first equation in slope-intercept form. Let's go ahead, do the second part of the problem. We need to write 3x minus 5y equals 15 in slope-intercept form. Do that, add a 3x to both sides, and we get, actually we're not going to add, we're going to subtract, so ignore that. We need to subtract 3x, giving negative 5y equals, and that I'm going to write as negative 3x plus 15, or 15 minus 3x. Next step, divide by negative 5 on both sides. Y equals negative 3 divided by negative 5 will be a positive 3/5 x, and then 15 divided by negative 5, negative 3. And then if you don't remember, our first equation was y equals 3/5 x plus 19 over 5. So you should notice that they have the same slope, but a different y-intercept, which means they have the same slope, so they can be parallel, and because they have a different y-intercept, they are parallel. If they had the same y-intercept and the same slope, they would be the exact same line. Last problem, number 7. There's a linear relationship between the number of grams of fat and the total number of calories in fast food sandwiches. In a hamburger, there's 8 grams of fat and 250 calories. In a Big Mac, there's 28 grams of fat and 540 calories. Find the slope of this relationship and interpret its meaning in the context of the situation. We will not need to find an equation of a line. So notice that they give you two different variables. They give you grams of fat, represented by G, and they also give you calories, which they tell you to use C as. We have two variables, so we can think about plotting a graph between these two variables. We're going to use C on the y-axis and G on the x-axis. Kind of write this side by side over here. And then it gives us two coordinate pairs. First, it tells us that a regular hamburger has 8 grams of fat, 8G, and 250 calories, so we put 250 for C. And then the other point is the Big Mac, which is 28 grams of fat and 540 calories. So we have 2 points. We can use the slope formula. Look at problem number 6 if you need a refresher on the slope formula. I'm just going to plug in the information right away. 540 minus 250 divided by 28 minus 8. This reduces to 290, or simplifies to 290 over 20, which then reduces to 29 over 5. Actually, 290 divided by... Let me calculate that one more time. Hold on. Actually, I think it goes to, let's see, 145. Divide both by 2 over 10. And then divide it by 5. $29 over 2, there we go. So a reminder that on the top we had C, and on the bottom we had G grams of fat. So if we're going to interpret this in terms of the problem, we would say that for every 2 grams of fat, we increase C, calories by 29. Alright? I believe that is all of the problem. We don't need to find an equation of a line. I hope this helped out. If you have any questions, feel free to email me or Dr. Koziak. I'm sure she's open for some office hours. And again, I apologize if I'm mumbling a bit or if you heard some sniffles and coughing, a little bit of a cold. All right, have a good day.